Hi everybody, in this video I'm going to go over our first test of spring semester. So for number 1, we're going to go through each of the answer choices and see why the ones that are not right are not right and why the one that is right is right. So first for the givens, it does tell us that BC is parallel to DE. So in small triangle, I have a right angle already, and in big triangle, I also have a right angle. So those angles are congruent to each other because all right angles are congruent. So that is one pair of angles between the small and the big triangle. And I also see that angle A is shared between the small triangle and the big triangle. So that's congruent to itself by the reflective property. So small and big triangle are similar to each other by AA. So now that we know that they're similar, we can set up a proportion involving their corresponding sides because the corresponding sides of similar triangles are proportional. So let's take a look. AC is from small triangle. BC is also from small triangle. That's fine. These two just need to be from big triangle. These need to correspond, and these need to correspond. So let's see. Does AC correspond to DE? AC corresponds to AE, not DE. So that's not correct. Goodbye, answer choice 1. Answer choice 2. AB is from small triangle. AD is from big triangle. And let's check if AB and AD correspond. AB and AD do correspond. Now let's just check that this is small over big and that they do correspond to each other. So BC is from small triangle and it corresponds to DE from big triangle, which is exactly what's here. So this is a correctly set up proportion. Let's take a look at 3 and 4 and just talk about why they're not correct. So AC is from small triangle. CE is not from any triangle. That's not a side of small triangle. That's not the full side of big triangle. That's not correct. DE is from big triangle. BC is from small triangle, and they do correspond. So let's just check that this is also big over small and that they do correspond. DB, that's not from big triangle. DA would be from big triangle. DB is not from small triangle either. BA would be from small triangle. DB is not from any. Goodbye, answer choice 4. Okay, let's take a look at number 2. So we know that DE is parallel to AB from the givens. So since we have parallel lines, corresponding angles are congruent in the small and big triangles. And they also share angle C by the reflexive property. So we do know that small and big triangle are similar. And once we know that triangles are similar, we can set up a proportion involving their corresponding sides because the corresponding sides of similar triangles are proportional. So I can set up a proportion here, or I can use the scale factor to find DE, which is what I'm looking for. I'll just set up a proportion here because a lot of people were doing that on their actual test. So I'll do small. So 15 is the side from small triangle over the corresponding side to it from big triangle. So that would be 15 plus 9, which is 24, is equal to X because that's the other side from small triangle that we're finding, over the corresponding side to it from big triangle, which is 40. Let's cross multiply. 15 times 40 is 600, and that's equal to 24x. 600 divided by 24 is 25, and that represents the side that we're looking for. You should also find the same answer if you were to use the scale factor instead of setting up and solving a proportion. The next one is the same idea as number 2, except it was like a real life situation word problem. But all we're doing is finding the distance from points B to C. Since this is a real world situation, we do know that our right angles here are congruent to each other. We do know that angle A is shared between the small and big triangles. So small and big triangles are similar, once again, by AA. So we can set up a proportion to find the missing side length because the corresponding sides of similar triangles are proportional. So let's do it. I'm going to set it up the same way. I'm going to take a side from small triangle over the corresponding side from big triangle, which would be 230 plus 85, and that's 315. Be careful, some people were using 85 as the corresponding side, but 85 is not from small or big triangle. I use small on top, so I'm going to use small on top again with the 120. And the side from big triangle that corresponds is x, which is what I'm trying to find. So we have 230x is equal to 315 times 120. So that is, when I multiply these, I got 37800. And then I'm just going to divide by 230. And it says to round to the nearest yard. That's the nearest whole number. So that's about 164 yards. I got on my calculator 164.347. So that's approximately 164 yards. Okay. Moving on to the next one. A lot of people didn't answer the question. The question is asking, are the triangles similar? You do have to answer the question. You don't have to have an explanation, but your work does need to show your answer, and you do need to answer the question. But if you did choose to explain your answer and you explained something incorrectly, that did lose points, because if you write something incorrect, of course, that is going to lose points because it's not correct. Okay, so RS is 6. ST is 14, XY is 9, YZ is 21, and angle S is congruent to angle Y. So already I see the congruent angle in between the two sides that have measurements. My mind is automatically going to SAS. As long as the sides are proportional, then SAS will definitely work. So 14 from small triangle, that's TS. Second and third letters corresponds to second and third letters here, YZ. 21 over 14. Let's get that scale factor. Divide those corresponding sides. And let me divide the other two corresponding sides. So you do need to answer the question. So you can write yes, the triangles are similar by SAS, or yes, the triangles are similar, the corresponding sides are proportional, and the angle in between is congruent. Or since it just says justify your answer, you can simply just write yes, the triangles are similar. That's enough. That means you answered the question. You can't just leave it like that. You have to answer the question. You have to say yes, the triangles are similar, or no, the triangles are not similar. Coordinate proof. Couple of things. Lots of people got this one wrong, and this was meant to not be a super hard question like 2-column proofs. So when you have a coordinate geometry proof, remember that you don't write a statement reason chart. Like as soon as you see that grid, as soon as you see these coordinates, think in your mind, like, I am not writing a 2-column statement reason chart. Instead, I'm going to figure out what formula to use. And then after I use my formula, then I'm going to write a concluding statement in words explaining what my calculations show. I'm just going to take a second and graph the triangles. So here I have graphed the triangles so that you could see triangle RST and triangle RUV. And I just did the question in one way so that you could see the format of a coordinate proof. So I used SAS here. I noticed that there's no confusion about how I prove the triangle similar because I have a concluding statement explaining in words what my calculations show. So my concluding statement is that triangles RST and RUV are similar by SAS. The corresponding sides are proportional by a scale factor of 3, and angle R is congruent to angle R by the reflexive property. And then if you look to my work, you see that I actually showed that the corresponding sides, RS and RU, and RT and RV are proportional. I found their lengths, and then I divided big over small to get the scale factor, and I found that the scale factors were both the same. So this is one way of doing it, but keep in mind the format of a coordinate geometry proof, formulas and calculations, and then a concluding statement explaining what your calculation showed. This is the format to get full credit on the coordinate geometry proof, on tests in this class, and also on the Regents exam. Another way that people were completing this question is some people were saying that ST and UV were parallel, so that made corresponding angles congruent, so the triangles were similar by AA. That's fine. You just actually need to show that these lines are parallel. You can't just say they look parallel or they're straight lines. We show that lines are parallel with slope formula. So you can use slope formula to show the lines are parallel, that they have the same slope. Or you can use rise over run. But if you're doing that, you need to make it clear on your paper how you knew that the lines were parallel. You have to say that the slopes are the same. You have to say what the slopes are. You can't just say the lines are parallel because they look parallel. You actually need some calculations on your paper. Okay, here we're dividing up the line segment in a 4:5 ratio. So our fraction is going to be 4/9. Remember, it's the same steps for the x coordinates and the y coordinates. The first step is the change in x and the change in y. So the change in x would be 22 minus 4, and the change in y would be 2 minus 2. So this is 18. This is 0. Then, to our result, we multiply by our fraction. That's how we're going to be dividing the line segment. This one's easy. It's just 0. Let me get my calculator out for 18 times 4/9, and that's 8. One more step, we add the starting x coordinate. So the x coordinate of our start point is 4. And to here, we add the starting y coordinate, which is 2. And here we have our point, 12, 2. That's the point that splits this line segment in a 4:5 ratio. It's 4/9 the way down the line segment. It's a 4:5 ratio. Okay. Here we have a fill in the blank proof. So when you have a fill in the blank proof, it might be a little bit tricky because you have to follow somebody else's reasoning. It also might be a little bit easier in some cases because you have like kind of a direction to go in. So some people like them, some people don't. Let's take a look. HM congruent to AT. HT congruent to AM. HE perpendicular to MEA. And HA perpendicular to AT. We need to prove that TA times HA is equal to HE times TH. So here are my two focus triangles. So since HE is perpendicular to MEA, I know that this is a right angle. And since HA is perpendicular to AT, I know that this is a right angle over here. So already in my two triangles, I have 1A, I have the right angles. Since we're proving a product, I know that before we can prove a product, well, first of all, I know that that's the very last thing we're going to be proving, right? We always prove our proof statement. And it's always the same reason anytime we're proving a product. In a proportion, the product of the means equals the product of the extremes. Remember, that's how we justify cross multiplication. So before we can prove a product, first we need to prove a proportion, just like the reason says, in a proportion. So we need to prove a proportion, which is step number 9. And to prove a proportion, it's always the same reason every time as well. Similar triangles have proportional corresponding sides. So in our reason here, it tells me what needs to come before proving a proportion. In order to know that we can make a proportion, in order to know that corresponding sides are proportional, we have to have similar triangles. And we know that we're going to be proving triangle HEA, similar to, let me get that other triangle name, THA. And since this is a 2-column proof with no numbers, we know that means we're going to be doing that through AA. So we really got the end of the proof down. We just need to figure out how that AA is going to come from. So now let's backtrack to the front of the proof. Our first step is our givens, or at least most of the givens. I see that it only includes the givens from here to here. So that means the rest of the givens are going to be somewhere in the proof at a later time. It also means that I'm not going to be mentioning the right angles just yet because that's not part of the givens here. Okay, now it's saying I'm supposed to know that this quadrilateral math is a parallelogram. So let me think about what I know about the quadrilateral that would make that true. And from our givens, the only thing I see other than the right angles is the fact that these sides are congruent and these sides are congruent. So I'm thinking it's a parallelogram because both pairs of opposite sides are congruent. So I'm going to write here a quadrilateral with both pairs of opposite sides congruent is a parallelogram. And now in step 3, after we know it's a parallelogram, we're supposed to conclude that HT is parallel to MA. Well, if it's a parallelogram, I know that's true because opposite sides of a parallelogram are parallel. And now that we know the sides are parallel, we're supposed to conclude that angle THA is congruent to angle MH. And if I highlight the parallel lines from our previous step and the transversal, I see my letter Z, and these angles are in the corner of the Z, so these are alternate interior angles. So if parallel lines are cut by a transversal, alternate interior angles are congruent. So that's going to give me 1A for AA. So the only other thing left to mention to get that AA are these right angles. So that makes sense that now the next given would come. So I could put down the part of the given that was talking about the perpendicular lines, because that's where I got the right angles from. So that's HE is perpendicular to MEA. And what was the other one? HA perpendicular to AT. So from the givens, we did conclude that angle HEA and angle HAT are right angles. And that was from having the perpendicular lines. We know that perpendicular lines form right angles. And since we know they're both right angles, we can say that they're congruent to each other. And that's due to all right angles being congruent. And that's our second A for AA. Now we know the triangles are similar, we can prove the proportion, and we can prove the product. And we're all done. So this was 12 points, not 10. Sorry about the typo. Each fill in the blank was 1 point, each thing that was missing. So there were 12 things to fill in, so that's 12 points in total. Okay, let's take a look here. So we want to prove triangle BCA, that's the big triangle, similar to triangle CDA, that's the small triangle over here. And we're told that we have right triangle ABC, and that in right triangle ABC, in the big triangle, angle C is the right angle. And we're also told that CD is perpendicular to AB. So that does mean there are right angles formed here. But let's talk about which right angle is going to be important. We are not proving anything about this other small triangle. The two triangles that we're proving similar are the big triangle, BCA, and the small triangle in green, CDA. So we do not need this right angle. We only need the one that is inside of the green triangle. So we have now one in the big triangle and one in the smaller green triangle. So that's 1A that we can use to prove the triangle similar. Now we need the shared angle. There's always going to be a shared angle because the small triangle is inside of the bigger triangle. And that shared angle is angle A. Angle A is in the small triangle. It's also in the big triangle. So those are our two angles for AA. Just for the purposes of this video, I'm not going to write down all the givens. You do need to on a test or the Regents exam for full credit, but I am not going to write it down right now in this video. We can see the givens up here, and we put them in the diagram already together. So now I need to state how I know this is a right angle. So I'm going to put here angle CDA is a right angle. And I knew that from in my givens, it had the perpendicular lines. And I know that perpendicular lines form right angles. Okay, now that I know that that's a right angle, I can say that angle CDA is congruent to the right angle in the big triangle, angle C. And that will be 1A that I need for AA, because that's the right angle in the big triangle and the right angle in the small triangle that we're proving similar. And our reason for that is all right angles are congruent. Then I just need to mention angle A being congruent to angle A, and that's by the reflexive property. And that's our second A for AA. So after that, we can say that triangle BCA is similar to triangle CDA, which was our goal in part A, and that's by AA. Now we just have part B. So in part B, we're going to be proving a product. And before a product comes a proportion. So my proportion, that's going to cross multiply to get me this. And what step am I up to? I'm up to step number 6. Is going to be the first term here divided by the last term here equals to the first term here divided by the last term here. And if you double check, that does cross multiply to give you the product that you need. It's always the same reason every time when you're proving a proportion. Similar triangles have proportional corresponding sides. And then from there, we can prove product that we actually need to prove. And it's the same reason every time. In a proportion, the product of the means equals the product of the extremes. And the last thing to go over in this video is the extra credit. This is Regents Review. Remember that a centroid is where the medians, the 3 medians of a triangle meet. And a centroid is special because it splits the medians in a 2-to-1 ratio. So if this is the median and that's the centroid, I know that this median is being split in a 2-to-1 ratio. So this is the 2 part of the ratio, the longer part. And this is the 1 part of the ratio. QC is 5x, and CM is x plus 12. And that means that if we double the smaller part, we get the larger part because the larger part is double the smaller part. So that's 2x plus 24 is equal to 5x. That is 3x. So we have x is equal to 8. And it was asking for the whole length of QM. So 8 times 5 is 40. 8 plus 12 is 20. 40 plus 20 is 60.